Statisticians, welcome. My name is Mr. Juba, and let me be the first to welcome you to the wonderful world that is statistics. By day, I'm a mathematician and math teacher, and by night, a practicing data scientist and statistician. I enjoy combing through mounds and mounds of data and understanding how that data is used to influence decision making and other aspects and phenomena that we operate by in our world. Our first lesson is going to take us through how data can be misleading. So for this lesson, our learning objective is going to identify the individuals and variables in a set of data. So I can classify variables as categorical or quantitative and make and interpret bar graphs for categorical data. I'll know I've got it when I can identify what makes some graphs of categorical data misleading. On our right-hand side, we have some vocabulary terms that are going to be associated with this particular lesson and aligned to the course textbook. Without further ado, let's jump in. All right, so before you, we have a graphic of the services that Planned Parenthood offer. Planned Parenthood is a women's healthcare clinic. So aside from cancer screening and prevention services, Planned Parenthood also offers the ability to obtain an abortion. Today's key analysis is: have abortions at Planned Parenthood drastically increased based on this graphic, which was shared at a 2015 Planned Parenthood congressional hearing. Before we get there, we need to comb through and establish some foundational baseline vocabulary words. So data that is considered quantitative is data that is represented numerically. Think of quantities, typically a measurement. Oftentimes, we can line the values up in order. Examples include your body weight, number of AP classes, SAT scores, blood pressure, etc., etc. And we can use histograms or box plots to represent quantitative data. Categorical data is data that fits in an individual into one of several categories that don't have an order. This data is typically represented by counts or percentages and isn't a number. Think qualitative data: eye color, race, gender, social security number, etc. So we're looking at characteristics of individuals, like how many people are wearing a navy shirt. That would be considered a categorical piece of data. Graphically, we can represent categorical data using bar plots, bar plot, or pie chart. All right. So below we have Catherine, who thinks that a zip code is a quantitative piece of data, but Brian thinks that the zip code is actually categorical, even though it's a number, since it doesn't make sense to average two people's zip codes. Who's correct, Catherine or Brian? When you make your selection, provide some evidence to support your claim and share that with your classmates so we can create some dialogue and see what everyone else is thinking. In this slide, we have a card sort. A card sort is basically an electronic matching game, which just happened there. So in this card sort, you'll be sorting all of these cards into two piles and identifying whether or not the graphs provided and the descriptions provided are categorical or quantitative. As you start to match up your cards, so let's take this pie chart for instance, which we stated in the previous slide is a categorical variable. Notice, let's just separate that, right? I have a counter down below that lets you know that you have 2 out of 14 cards correct. So this will help you in attending to precision. If it seems a little bit small, you can select the card and it will magnify its view for you. So sometimes, humanity doesn't necessarily do the right thing, and we have people or organizations that make misleading graphs to try to tell a story that's not exactly accurate. I'm sure in the past 365 days with the 2020 presidential election, you were made aware through various forms of social media of misleading graphs that may not have represented the entire truth. We call that BS. And in the world of statistics, yes, BS is bad statistics. And we're going to spend a lot of time over the next 10 months um, identifying what bad statistics look like and how we can make certain adjustments to make bad statistics good statistics. So the first example we'll work through is Kobe Bryant, the Hall of Famer in the 2009-2010 season, made 9.8 shots per game and had 5.0 assists per game on average. Now, if you've ever watched Kobe Bryant play basketball, he is what we consider in the athletic world a shark. He is a pure scorer and wants to get to the basket and will stop at nothing to accomplish that goal. Even if it means taking on 5 players at one time, he'd rather, or it appears, would rather shoot the ball 5-on-1 than find the other 4 empty teammates. So we have this graphic here where the made shots is this larger basketball, and his assists are represented by this smaller basketball. The large basketball is intended to represent the quantity 9.8 and the assists 5.0. So very quickly, how can we determine, or what aspects of this graphical display make this representation misleading? As you are combing through your thoughts, I suggest you pause the video as I'll continue on below. So there are certain characteristics that we can look to identify in order to spot a misleading graphic. One of those things is that the graphic may not have axis labels or a scale. It may cut off the X or Y axis or start at a weird place. And we'll go back to that original graphic regarding Planned Parenthood and see how that comes to fruition. And it may use pictures or bar graphs and refer to it as a pictograph. So you should have already typed your response to how the pictograph below, or I should say to the left, could be misleading. But take a look below. I've re-represented Kobe Bryant statistics using a bar graph. And we can see here, right, that Kobe Bryant makes double the amount of assists, and it's much more uniform and consistent because the width and height of each of the bars is consistent or symmetrical. In the basketball representation, the assists ball is 1/4 the size of the larger ball. So even though the larger ball is only designed to represent twice the amount of assists, it is visually enlarged to 4 times the amount or 4 times the image that's being used to represent the assists. So this is a classic example of how pictographs and graphs in general, graphics, can be generated or created to be misleading. So we're going to return back to that original Planned Parenthood graphic. Oop, for some reason, now let me look. Can I zoom in? Let's see. Control plus. There we go. Oh, perfect. All right. So Republican Jason Chaffetz stated that that's the reduction in breast exams, and the red is the increase in abortions. That's what's going on in your organization. So we can clearly see that there is indeed an upward trend in the number of abortions and a downward trend in the number of cancer screenings and prevention services. What story is this graphic telling? And is that story misleading? This is your discussion question for this particular video. Once you finish that particular question, there are 2 mandatory slides you must complete. These 2 slides will provide an opportunity for you to reflect on key points from the video so you can come to class ready to discuss and practice, and also allows me the opportunity to gauge your comfort level with the material and adjust lessons accordingly. So, in your own words, explain the difference between quantitative and categorical data, and in what way was the basketball pictograph misleading? Lastly, how comfortable do you feel with the content covered in this video? Rated on the following scale. As soon as you make a selection, you'll have an option to provide any additional questions you have regarding the content covered in this video. And when we resume together in class tomorrow or 2 days from now, whenever it is that I see you, if you're working on this over the weekend, we will tackle the enhancement opportunities and come up with a comprehensive understanding of how data and graphical representations can be misleading. I hope you enjoyed this video, and I'll see you in lesson 2.